Hello everyone, welcome to UpSmart. So this is your Reddy Prakash. I have cleared CAPF AC 2024 Assistant Commandant Examination and various other examination as I told you in the chapters of while discussing the chapters of biology. So without wasting time, let us now get into the third chapter of chemistry. In the first chapter, we studied everything about the matter. In the second chapter, we studied everything about the acids, bases, and salts and how they react with metal oxide, carbonates, etc. Okay, this is fine, right? These two chapters sets the basis or the foundation for the coming chapters. Now what are atoms and molecules, sir? Atoms and molecules. This will be our third chapter. In this chapter, we'll be studying atoms, molecules, mass, atomic number, valency, and various other concepts like Avogadro's number and moles, etc. Okay, so let us now get into the history part of it, which are not very much asked in the exam, so that I minimize the content regarding the history. Only the very important facts are mentioned here. Firstly, Maharishi Kannad, our Indian philosopher Kannad, Maharishi Kannad gave Kannad theory. What he said is, he proposed that matter is made up of tiny indivisible particles, today which is named like atom. Now it is named like atom, but 2500 years ago only, our Indian philosopher Kannad, Maharishi Kannad, he named those atoms like Parmanu, which cannot be divided further. Okay, and then came Democritus and Leucippus. They came after Kannad. So what they did is, they called the smallest particles as atoms, which are indivisible. Cut, copy, paste. They gain the credit, we gain the knowledge, it seems. Maharishi Kannad gave this concept. These English wale copied everything, they gained the credit, and they are telling they can civilize us, it seems, and we are accepting it. Next is Antoine Lavoisier. He laid the foundation of modern chemistry. Not much important again to say, just remember enough. Next is laws of chemical combinations. In this, two laws are very important. One of them is law of conservation of mass. This was given by Lavoisier. Lavoisier gave the law of conservation of mass. Lavoisier gave the conservation of mass theory, that law. And there will be second law of constant proportions, given by Joseph Proust. Proust gave the constant proportion theory. Okay, we'll see what is conservation of mass theory given by Lavoisier. See, when a matter is neither created nor destroyed in a chemical reaction. Chemical reactions happen, right? Say, acids and bases, how they react? Through neutralization. What Lavoisier observed is, the matter of acid, the matter of base, neither of them are not destroyed. They are not destroyed. They just change the form. They are not destroyed in a chemical reaction. Total mass of reactants is equal to total mass of products. What are the reactants? HCl, NaOH. The mass of HCl plus NaOH is equal to the mass of NaCl plus H2O. The mass will remain. The mass will conserve as it is. So it is named like conservation of mass given by Lavoisier. Easy, right? Fine. Next is law of constant proportion given by Proust. What this person says is, a compound will always contain same elements combined in same proportion by mass. When a compound is there, a compound means HCl is a compound, NaOH is a compound always contain same elements combined in same proportion by mass. Meaning, say, water always contains hydrogen and oxygen in the ratio of 1/8 into mass. Meaning, okay, I'll tell you. Say H2O H2O is a compound. It will have 2H divided into H and one O, right? So the proportion of H and O will be the mass of H and O. Mass of H is, we'll get in the concepts of mass of elements. Before that mass of hydrogen is 1. Mass of hydrogen is 1 unit. Mass of oxygen is 8 units. So the proportion will be 1:8. The proportion will be, water always contain hydrogen and oxygen in the ratio of 1:8. 1:8. So what it says is constant proportions. The proportion will not change in a compound. Proportion will be as it is. This is given by Proust. Law of constant proportion. Easy. The other important theories. Apart from this, the most important being obviously Dalton's theory. Dalton's atomic theory is the most important one. So other theories like law of multiple proportions, also given by Dalton. Dalton also gave law of multiple proportions, but his most important theory is being atomic theory. If a question is asked, it will be asked on atomic theory, usually 99% of the time. But we should also be prepared for that 1%, because ultimately only 1% of the students will get through the examination. Stay smart, stay connected with UpSmart subscribers. Okay. Next, law of multiple proportions. John Dalton gave this. What this person says is, when two elements form more than one compound. See, these are two elements. C and O are two elements. It can form either carbon monoxide and it can also form carbon dioxide. When two elements form more than one compound, the mass of one element that combined with the fixed mass of the other are in simple whole number ratio. Simple whole number ratio. This is what he gave. When two elements has an ability to form multiple types of compounds, the mass of first element in proportion to the mass of second element will always be a whole number. It will always be a whole number. This was given by John Dalton. Now his most important theory, that is atomic theory. He gave a few postulates which are very important for the examination. One of them being matter is made up of tiny particles called as atoms, which was given by, don't name atoms, was given by Cunard. Though it was given by Cunard, he didn't name it as atoms, he named it as Parmanu. Atoms as a name was given by Democritus and some other person. Mention that some other person's name in the comment. Okay, I'm doing this because you should remember the names. Now, he repeated that postulate. In his theory. Other things being, atoms cannot be created nor destroyed. It cannot be created nor destroyed. It was given by Dalton. And other postulate being, atoms of the same element are identical. Atoms of same element are identical. Hydrogen atoms, regardless of where it is, how it is, with whom it is, it will be identical to any other hydrogen atom. Easy. Next, atoms of different elements are different. Hydrogen atom, chlorine atom, regardless of where it is, how it is, with whom it is, it will always be different. It will never be similar. Next is atoms combine in simple whole number ratios to form compounds. Something which he gave earlier, similarly he gave it here. Easy. However, there are few negatives or limitations or drawbacks for Dalton's theory. One of them being, with the improvement of microscopic observations in chemistry, that is, with improvement in observation, it was found that atoms are divisible. Atoms are not until then the theory was atoms are the tiniest particles of a matter, it cannot be further divided. But it was found that atoms are divisible into protons, electrons and neutrons. Protons, electrons and neutrons. So this is one drawback. The other thing being, isotopes have different masses. What he told, atoms or compounds, if similar, then it will become very similar, something like that he gave. But a clear going into depth is not required. Isotopes have different masses, though it is similar. Isotopes 14C and 12C are isotopes, but it will have different mass number. Isotopes have different mass number. What he told us, regardless of where the element is, how the element is, the mass will remain same as it is. But if you see now, 12C has different mass, 14C has different mass. So this is one drawback. Atoms of same element are identical. Is it really identical? No. Next, isobars have same mass number, but different elements. Argon and calcium both have mass of 40, but different elements. Argon and calcium are not same. Those are different elements, but same mass number. What he told? Atoms of different elements are different. These are different elements only. Atoms of different elements. Atoms of argon, atoms of calcium. But similar in what? Mass. These are mass. Similar in mass. These are the drawbacks of Dalton theory. Understood? Easy. Let's move to the next slide. That is the what is an atom? How an atom is represented. See. Atoms are smallest particle of an element that takes part of a chemical reaction. Those are further divided into PEN, that is proton, electron, neutron, that we know. Smallest atom is hydrogen. I'll teach you the table. What table? Compound table. I'll teach you that element table, chemical table. Okay. Next is atomic radius. Atomic radius means an atom will be there. What is the radius of the atom? That will determine the size of the atom. Size of an atom it will be measured in nanometer or picometer. That is the atomic radius. Next is instrument used for this observation is scanning tunneling microscope, STM. Scanning tunneling microscope is something which is used to observe the atoms. Next, symbols of atoms. Those symbols of atoms was given by J.J. Berzelius. Berzelius gave the symbols of atoms, like the first symbol being the hydrogen, second symbol being the helium. He gave those symbols, Berzelius. Okay. Next is, now this is important. This is something conceptual also. Okay. See, hydrogen, symbol of hydrogen is H. Symbol of helium is He. Everyone know this. Symbol of lithium is Li. Beryllium, hydrogen, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium. You have to mug up these numbers. These numbers are called as atomic numbers. In a periodic table, in a chemical table, these are called as atomic numbers. Each element will be having a different atomic number. Atomic number won't be same for any element. Atomic number will be different. And you have to mug up the first 20 atomic numbers of elements. Pakka. You are not missing it out. Okay. Next, you have to mug up the symbols as well. Arts wale. This is something I can't help you. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. You have to mug up this 1 to 20. This is easy, sir. I can mug it up. It is about 2 minutes of time. So my friend, what is difficult now? The difficult part of is, you know the atomic number. You should also know the mass number, which I'll give you. Right now I don't want to make your things complex. This is enough. Screenshot this slide, mug it up. Even before getting into the next slide, I want you people who are watching the class to pause it, mug this table for 2 minutes. Mug it up. Do the ratta learning, rote learning, by heart. Kuch to kar lo yaar. I want you to know the 20 atomic numbers right now. before getting to the next slide, pause it. 2 minutes. Okay. Now, what is electronic configuration? What is valency? You have paused it, right? You have studied, right? I'll get into this concept now. Okay. I'll take a whiteboard. See, what happens is the elements or electrons are arranged in circular pattern like this. Shells. These are called as shells. These are called as differentials. The differentials are named through letters. This one, the smaller one, is called as K shell, L shell, M, N, KL, MN, KL, MN. The smaller shell, the innermost shell is called as K, KL, MN. This is how the arrangement of electrons in an atom happens. Clear with this arrangement of electrons in an atom. Now, the other thing I want you to know is, you know the atomic number, right? Now you know the atomic numbers. I told you to mug up those atomic numbers. Atomic numbers are equal to number of electrons of that element. Hydrogen has 1 electron. Helium has 2 electrons. Similarly continues till 20. Now you know the number of electrons because it is similar to atomic number. You have studied the atomic number, right? You are watching this means you are not understanding anything. You have to pause it. You have to study that. Now we are watching this. Clear with that? Those are not the orders, but consider it as a request here. Request. Okay. Atomic numbers are equal to number of electrons. Clear with that, right? Now see. Now, what happens is, hydrogen has 1 electron, helium has 2 electrons. Helium has 2 electrons. Beryllium has 3. Boron has 4. Understood, right? This is how it goes now. The flow. Now what happens is, I told you the shells. I told you the shells. Now, how many electrons each shell can cater? How many electrons each shell can cater? How many electrons each shell can cater? Each shell can have it. Capacity of each shell. Now, it is a concept. See, K shell can have at max of 2 electrons. L shell can have at max of 8 electrons. M 18. This is at max enough for you. K, L, M, N. Okay. At max this is enough for you. 2, 8, 18. But until the 20th atomic number, M shell usually can cater only 8 electrons. Beyond the atomic number of 20, beyond the elements which have atomic number of 20, it can cater usually 18 electrons. Now what happens in this 2, 8, 8, 18 is, now this will determine the electronic configuration. What is electronic configuration, sir? Now the atomic number of H is 1. Atomic number of H is 1. So if it is hydrogen, it will have 1 electron here. If it is hydrogen, it will have 1 electron here. So the remaining minus 1. One is occupied, the other one is valent. It is empty. So the electronic configuration now of hydrogen, electronic configuration and valency. These are two concepts. Electronic configuration of hydrogen, electronic configuration of helium, electronic configuration of beryllium. Electronic configuration of hydrogen, helium, beryllium. We'll understand this now. Now, one electron is there with hydrogen. It has to be kept in K shell. So the electronic configuration of K, electronic configuration of hydrogen will be 1 only. It will be 1 only. Electronic configuration of hydrogen will be 1 only. But valency, how many are empty in K shell now? How many are empty in K shell now? 1 is empty, so that will be valent. 1 valency. Now the helium. Helium has 2 electrons. Helium has helium, lithium. Lithium is 3. Sorry. Beryllium, boron. No, this is lithium. Sorry with this. A slight confusion which is human in nature. I hope you will understand. Sorry with this. So 1 is valent, 1 is empty. Electronic configuration 1, valency 1. Second one is helium. Helium has 2 electrons. Both the electrons, K can cater both the electrons. So the electronic configuration is 2. Electronic configuration is 2. Now how many are empty in K shell? There are 2 slots. Both are catered already. Both are filled already. Both the slots are filled. How many are empty? No empty. So the valence is 0. Easy. Now the lithium. Lithium has 3 electrons. 2 can be catered in K shell. The other one will be catered in L shell. So the electronic configuration is 2 from K, 1 from L. 2, 1 is the electronic configuration. What is the valency? 0 in K, need not mention. We should go to the valency, means what are the number of slots left in the last shell. The last shell of lithium is the L shell. The L shell has 7 spots left. So the valency is 7. This is the concept of electronic configuration and the valency. Electronic configuration and the valency. So this is not there in the slides. For people who joined our course and the people who didn't join our course, regardless, take a screenshot of this. You can write it later, or you can pause the video for a minute or two. Think what I explained for 2 to 3 times. Write it down again and again. You can practice once or twice so that you don't forget again. Fine. Easy concept. Now we'll go to the slides. Now see, hydrogen, helium, lithium, beryllium. Hydrogen, helium, lithium. Atomic number 1, 2, 3. Electronic configuration 1, 2. Valency 1, 0. Lithium, electronic configuration is 2, 1. Valency is, total valency is 7, no sir. Why the valency is 1, sir? Why the valency is 1 now? You answer. Why the valency is 1 now? Can you observe valency of 7 or anywhere? Can you observe valency of such big nature? Can you observe that valency? Valency being 7 anywhere? Did you observe the valency of 7? No, but you told, sir. I listened, sir. I told, you listened. How many times can this happen? You can see the bigger numbers in the electronic configuration. How many they have filled? 2, 882, 2, 882, 2, 87. You can see all these in the electronic configuration. But you can't see similar bigger numbers in the valency. Okay, you can't see the similar bigger numbers in the valency. So why is it? Why we can't see the bigger numbers in the valency? What actually means by the valency? Now this is a question. Can you do a research about it? It is not very much complex in nature, but it is not equally important for the examination also. The concept is not very much important for the examination. What's important for the examination is what is the valency number, what is the electronic configuration. I'll teach you how much ever concepts are important for the examination, but there needs a slight efforts from your side so that you will get interested in the subject. Now, I told you a concept. I told you where you can trap it. If I didn't tell this trap, for sure you would have made this mistake in the examination. So I made you to get into a trap. Now you should resolve this trap by yourself. Google it. Why the valency of lithium is 1, not 7. Why the valency of lithium is 1, not 7. You have to Google it, research about it. If you know it already, comment it down. If you are studying it and still watching this video, comment it down. If not, you tell it is not easily understandable to me, sir. Kindly explain in the next class. I will for sure explain it. But right now, I need you to get clarity over few concepts in the chemistry. Chemistry is not very easy subject. Chemistry is a little bit tougher because it is boring. It is always some acid comes, some basic comes, some mass comes, some volume comes. All these things will be there, which will be really boring. I have converted these slides. I have made these slides colorful so that you will have some interest. I have made concepts easy. I am using the whiteboard as well as the colorful slides to make the concepts interesting. I need you to put in this little efforts wherever it is possible. Tomorrow class, I want everyone who are watching to tell why the valency of lithium is not 7 but fine. Similarly, electronic configuration, you won't be having a doubt of electronic configuration. Why 288 here? Because I told you until 20th atomic number, the valency, the KLMN shell will cater only 8 electrons but not 18 electrons. So 2 plus 8 plus 8 plus 2, that will give 20 atomic number. Beyond that, if it is 21, then it will become 2 plus 8 plus, it will finish up in the M shell only. Okay, until 20th atomic number, the capacity of M shell is 8, not 18. This is the concept. I am pretty sure electronic configuration concept you understood. I am pretty sure 50% of the valency concept you understood. You have a slight doubt which you will do in the examination. Get a clarity of it. Okay. I'll tell you in the next class. Next topic. Atomic mass, sir. Like there is a mass for our body. Like there is a mass for our body, there is a mass for atoms as well. Let us understand what are the mass. You see, hydrogen atomic number is 1. The mass number is also 1. What is the atomic number of carbon? Is it 6? Is the atomic number of carbon 6? Is it 8? What is the atomic number of oxygen then? I told you to mug up the table, not for fun purpose. You have to do it. Atomic mass of carbon is 12. Similarly, you have to mug up the atomic mass of all these compounds which are very important, especially chlorine. This is the one which is always asked in the examination because it is decimal in nature, 35.5. Okay. Now that is examples of atomic mass, sir. Now understood. Atoms also has weight. Those are the atomic mass. SI unit is unit. It is called as 1 unit, 2 unit, 3 unit, 12 units, 14 units, something like that. Now what is unit, sir? See, atomic mass unit. The unit is U. Now what is unit, sir? 1 unit is equals to 1/12 of the mass of carbon 12 atom. Carbon 12 atom is taken as an example. Carbon 12 atom will be taken as a standard, an example. Based on that, mass of other elements are calculated. They have taken a carbon 12 atom. They have considered 1/12 carbon 12 atom as the 1 unit. That means the weight of carbon 12 atoms is 12 units. The weight of hydrogen is 1 unit. Okay. Carbon 12 atom is assigned an atomic mass of 12 units. Carbon 12 atom will have 12 protons, 12 neutrons. Together they will make up 12 units. Easy. Next, what is molecule, sir? Atomic mass, I understood. What is molecule? Molecule is the smallest particle capable of independent existence and showing all properties of a substance. Now you told, we understood what are compounds. What are elements, what are atoms, what are substances like acids, basics, nature. Now what are molecules, sir? Molecules are smallest particles, smallest particles, like hydrogen can become H2, single oxygen element can become O2, oxygen, N can become N2, H and O together can become H2O, N and O together become N2O, nitrous oxide. These are the smallest particles. A molecule is the smallest particle capable of independent existence and showing all properties of a substances. It shows the properties of substances. Okay, these are particles. It can be hydrogen, oxygen, nitrogen, water, carbon dioxide. Easy. Now the atomicity. What is atomicity, sir? A city containing atoms is called as atomicity, sir. Correct. Number of atoms present in one molecule. Molecule is there, right? H2O is a molecule. CO2 is a molecule. What is the atomicity of H2O and CO2? What is the atomicity of H2O and CO2? It seems like 1H, 1O. It is 2H, 1O. Atomicity is 3. Similarly here 3. Here 2. See the examples. H2 is diatomic, 2 atoms. Triatomic means 3 atoms, O3. Similarly, something is P4 means phosphorus 4 means P4. S8 means 8. This is the atomicity. Atomicity. Number of atoms present in a molecule is called as atomicity. What is molecule? The particle, smallest particle, capable of existing independently, showing all the properties of substances, is called as molecule. Then what is molecular mass, sir? The sum of all the atomic masses of atoms. If it is CH4, the sum of carbon's atomic mass is 12. H atomic mass is H4 means H atomic mass is 1, but we have 4 hydrogens. So the molecular mass of HCH4 is 12 plus 4, that is 16. See, 12 plus 4, 16. Methane. Water, 2 plus 16 for oxygen. Similarly, other things. These are called as molecular mass. Molecular mass means we have to break down the elements of a molecule. We have to calculate the atomic mass of each element. Then sum it up. The total is molecular mass. Total mass of a molecule is called as molecular mass. How you calculate? We break down, add up. That is called as molecular mass. Next is important cations to remember. Cations means those ions which has plus over its side, those are called as cations. Those ions which have minus over its side is called as anions. Then what is cathode and anode, sir? This is opposite to that. Cation will have plus, cation will have plus, cathode will have minus. It can absorb minus particles. Then anion will have negative. Anode will be having positive charge. It is negative, opposite. Okay. Valency 1, valency 2, valency 3. You have to remember this. Remember these important ones, important cations and the valency of each. This is important for the calculations or problems which you get in the upcoming chapters. You have to mug up this or get a clarification of valency. What I gave an assignment, get a clarification of valency concept. Then you can get to know the valency of cations. Easy. But I tell you seriously, chemistry is some subject. The efforts are not, the amount of efforts you put is not equally the output. But you have to do it to answer those 3 to 4 extra questions. I am expecting UPSC to change its nature, because recently if you see, UPSC in its examination has been very unpredictable. Like the earlier biology in general science, CAPF used to get around 25 questions from general science. 20 of them used to be biology, 2 to 3 chemistry, 2 to 3 physics, and I don't know if this proportion continues for a longer duration. So I want you people to stay focused on these peripheral subjects like chemistry as well as physics. We never know what UPSC will do. I don't have words to explain what UPSC is. Okay, that is one thing. So next, important ions to remember. These are easy. Important ions. Hydrate means H minus. Hydrate means H minus. Then what is H plus? Chloride means Cl minus. Just remember the names. I need not explain. Similarly, polyatomic ions. You have to study this. Mug up the names. Okay. Next, important chemical formulas. You already know this. Hydrogen chloride, HCl. Hydrogen sulfide is H2S. H2SO4 is sulfuric acid. H2S is sulfide. Sodium nitrate, aluminum oxide, methane, aluminum nitrate, carbon tetrachloride. Tetrachloride because 4 are there. Potassium sulfate. You have to remember the compounds and the chemical formulas as well. Okay. Next is formula, unit mass, mole concept, Avogadro number. Not again, the amount of thinking you have to put in to understand the concept, to retain these concepts are, I feel sometimes like I feel pity for students who come from the arts and other background. I put in my maximum efforts focusing on those people, not these people coming from the science background. They can easily get these topics. They have a hold or a previous exposure to these topics so that they don't feel the difficulty. But people coming from arts background, commerce background, I want you people to focus, understand. I have simplified as much as possible. I have eliminated the concepts and other bakwas things where 99% of the times it won't be asked. Okay. So, what is formula mass unit? Sum of atomic masses of ions present in one formula unit. See, NaCl is one formula unit. This is a formula. This is one unit. Sum of the ions. What are the ions? Na plus is one ion. Cl minus is one ion. The sum is formula unit mass. This is the formula unit. The sum of those ions is called as formula unit mass. Easy with this? No. What is mole concept then, sir? What is Avogadro number, sir? Mole concept was given by Ostwald. Wilhelm Ostwald. Avogadro number. Number was given by Avogadro himself. He named the number by the name of himself. Avogadro number. Mole concept was given by Ostwald. Okay. This is the history. Now, this mole concept is based on Avogadro's hypothesis, Avogadro's theories. Avogadro number refers to number of particles present in each atom or each element, that is called as Avogadro number. Say this is a Avogadro's constant 6.022 into 10 power 23 is an Avogadro's constant. So what Avogadro told is the Avogadro number or one mole of oxygen contains the constant into that particle. Number of 1 mole of oxygen contains 6.02202 into 10 power 23 particles. Particles means like atoms, molecules or ions. These many particles will be present in a particular element. That is the constant. 1 mole of oxygen contains 6.022 into 10 power 23 particles. 1 mole of carbon contains same constant into number of particles. Similar, 1 mole of zinc contains 6.023 into 10 power 23 zinc particles. This is a constant. Now, what are moles, sir? We understood Avogadro number. The concept of moles is based on Avogadro number. We understood that. You are telling 1 mole of oxygen contains the constant into particles. Particles will be just a name I am telling you. The constant number of particles for every number. Then what is the number of moles, sir? Number of moles refers to this formula you have to remember. N is the number of moles. N. M is the given mass. M is the molar mass. Molar mass. What is the molar mass? the mass of a molecule is the molar mass. Molecular mass is the molar mass. What is the given mass? It can be like, they can keep it like 4H2O. They can give the mass of 4H2O. They can give the mass of 4H2O. Then they can ask what are the number of moles. Now the given mass is 4H2O, which will be, this will be 2 into 1 plus 16. 4 into 18 by molecular mass is 18. 4 moles. Number of moles is 4 here. N is equal to number of moles is equal to given mass into molecular mass. Given mass into molecular mass, right? And also number of moles is equal to number of particles divided by Avogadro's number. Number of particles into divided by Avogadro's number. Number of particles, because this will be having 4 into number of particles, that is 4 into 6.0223 into 10 power 23. But one water molecule will be having 6.022 into 10 power 23 only. So 4 into 6.022 divided by 6.022, it will cancel the Avogadro's number. The 4 will be remaining. So what we observe is these two formulas are same. M by M is equals to N by Na. They might now for a problem can be asked. They might give the values of 2 or 3 out of this. They might ask you to solve the problem. Now you know the concept. Now you know the formulas. By the formulas, how to get the answer. Now it will be easy for you. They will give the numbers directly. Not much to think. CAPF problems will be easy. Now key terms. Few of the key terms which you already know. We'll discuss this. Atoms is smallest particle of the element, which can be further divided into proton, electron, neutron. Next is molecule. Molecule means smallest particle capable of independent existence and shows the properties of substances. Next is atomicity. Atomicity means number of atoms in a molecule. Atomic mass unit. Atomic mass unit means 1/12th of mass of carbon 12. I told you carbon is a constant. Cation means positively charged ion. Anion means negatively charged ion. The opposite is anode and cathode. If it is negative, cathode. If it is positive, anode. Write these two because these are related but confusing topics. Next is polyatomic ion. Many atoms will be there, one charge will be there. Polyatomic, group of atoms carrying a charge. See, many atoms, one charge. Formula unit mass. Mass of atomic masses in an ionic compounds. We separate the ions, calculate the mass, sum it up, that is formula unit mass. A mole. Mole is a constant particles. Constant number of particles is called as mole. Avogadro number is this constant. Avogadro constant. Easy. Only one doubt and one trap I have put you in, that is the valency. Clearly I am telling again, get to know why the valency number is not greater, why the valency of lithium is 1, not 7. Okay, easy. So by this we'll wind up the chapter of atoms, molecules, those numbers, mass and various other things. So in the next chapter we'll get to carbon and its compounds. So for now we'll stop this class. Okay, thank you so much. Have a nice day. Study well. All the best for your future examinations. To stay connected, subscribe to our channel, share it with your friends. Thank you so much.